Good day. So today we've been working, this week we've been working on algebra, and today we're going to talk about how we connect that to geometry. So let's get started and see how this goes. So vocabulary that we need to learn. First of all, you should all know that area refers to the inside of a shape, and it's measured in square units. Okay. Real life examples would be like grass around the pool, a backyard, painting a wall, or some figures that are funny shapes that we have to break into smaller parts. And we're also going to be using the idea where we're going to have to solve for x, okay, using these area ideas. So there's the idea of a pool. You might want to find the area of the pool or the grass around the pool. Another one where we've got a couple of areas that you may need to add together and look at their volumes, sorry, not their volumes, their side lengths, and compare them. With perimeter, that's the distance around the outside, and I just thought of this today. You can think of the rim around the outside. Where we might see this is fencing around a pool, Christmas lights that you put around the house. It's a length around a shape. And algebraically, same deal, we might be using some of these shapes to determine questions where you have to find out the length of, or the value of x. So there's a nice little, that's not my house by the way, and a pool where you have a fence around the pool. So basic concepts. This is just the preliminaries that you better understand, all right? First of all, this is from the Algebra and Geometry section in your handout. So that I told you to put in the back of your duotangs. So please take a look at this, and we're going to take a couple of questions and pinpoint them, and let's see how you can follow. So first part I want to talk about is how we have totals for matching sides. So for example, I have the height in this shape in number 1, and it's 7 centimeters. So that has to equal the heights on the other side added together. So equivalent side lengths. In the same way, the horizontals, so that sometimes we can find missing parts because you know that those two sides at the bottom that are running parallel to the 10 have to add up to 10. And it doesn't always split it in half, so be careful about that. Another thing is knowing about area, where we have to break it into smaller rectangles. Okay, so for example here, I may have a break going down between those two shapes. And when you're looking at these, remember to break it up into two different shapes and label it very clearly which area you're doing, and that you're going to have to add them together at the end of it all. A plus B. All right, moving on to page 2 of the handout. This question is dealing with the ideas of equivalent side lengths. Now, the shape you see here, it's called a kite. And the way that a kite works is you have two pairs of sides that are equal. So this pair of sides is going to match, and the other pair of sides is also going to match. Those little tick marks on there tell you that they're equal. So don't fall into the trap of thinking that negative 2 times q plus 1 is going to equal to 6. Is going to equal to 2p plus 3. It's actually equal to 6. All right? So those are the two sides. They're actually adjacent to each other. They're touching. So we can set up that equation to solve. Reminder about how this works. You have to first expand the brackets if you can, and then you have to get the variable term by itself by eliminating the constant term on the side where the variable is, and then you have to isolate the variable by dividing by the coefficient. Hopefully by now this routine is pretty clear to you. Just a reminder that that's a letter Q, it's not the number 8, and make sure your Q doesn't look like a 9. So Q is equal to negative 4. And you could use this to replace back in to find out the length of that side, but actually we don't have to worry about that because we know that side has to be equal to 6, right? Because they're equal. Same kind of situation going on with the bottom of this kite. The 2p plus 3 has to equal the 9, so I can set up the equation there. And this is actually a little bit easier to solve because there's no brackets. So I can just subtract 3 from both sides, and that's going to give me 2p is equal to 6, and divide by the coefficient. I know you can do the answer in your head, but just to say, you're going to do the calculation that way. Mind your p's and q's, follow all the steps. P is equal to 3, and you can test it out by replacing it in to make sure it really is equal to 9. Fair enough? And then we would go on and maybe answer some other questions like, oh, now can you find the perimeter of this shape or the area? This one would be a little more complicated to find area. We're not seeing that until secondary 2. Okay? Okay, now we're flipping to the back page of your handout, or at least close to the back, page 6. Now this question is talking about the idea that you can subtract areas to find out missing parts. So the shaded area in this shape is basically equal to 72, and the way we're going to find the area of the shaded is going to be the area of the big rectangle minus the area of the white rectangle. Whoops, I'm not going to write the whole word. These are the abbreviations that we use for working this stuff through. So I'm setting up an equation, right? This is the left side, this is the right side, and I know that 72 is going to equal to the area of the big. Now, yeah, it's 2x plus 5 times 6, but we prefer to write the 6 in front. And the area of the small, which is the white region here, is going to be 3 times x plus 1, and with the reminder that we have to subtract. So watch out when it comes to expanding the brackets. How do we solve this? Well, I just said it. We're going to expand the brackets first. So on the right side, I'm going to get 6 times 2x and 6 times 5. The next bracket is going to be negative 3x, and remember to circle that so you don't forget the negative, and negative 3. First step, expand the bracket. Second step, simplify both sides. Well, obviously nothing to simplify on the left, but on the right, I've got my 12x minus 3x, and I've got my plus 3 minus 3. I need to isolate the variable term, so I'm going to get rid of the positive 27 by subtracting it on both sides. And be careful with the subtraction that you don't mess up. That's not going to be 55, it's actually going to be 45. Hopefully you can do that calculation on the side so you don't mess up the example. And I'm going to divide both of the sides by the coefficient. Now that I know the value of x is equal to 5, I can replace it in, because the question might say, what's the perimeter of the inside? In fact, I think that's what the question actually asks you for. So you replace in x equals 5, and you can tell me what those lengths are. 2 times 5 plus 5 is going to be equal to 15. And the x plus 1, 5, going in place for that x, is going to be 5 plus 1. So that side length is equal to 6. So obviously this is not drawn to scale, right? Because the 6 that we see on the side here looks different than the 6 we would see across the bottom. Okay, moving on. The bottom of page 4, I think this is. And we're looking for the area. Actually, this is the top of page 3. Okay, that's other parts for the homework. So, working with this shape, you're going to find the total area is 144. 3x times 12 is 144. How do I work that out? Well, you're going to set up the equation. 144 is equal to the length times the width. Divide by the coefficient to find out that x is equal to 4. Okay, so what has been given, and how do we build the equation? All right, so we're using that to find the equation. But now, as I said before, we're going to have to use that answer, x equals 4, to determine the perimeter of the inside shaded region. So in this case, for example, okay, I'm just going to put in x equals 4, okay, fresh picture here, put the 4 in for both of the x's to find out what the length and the width are equal to. So 4 plus 2 is going to be 6. And that's this inside part, right? And the x is going to be the height of this part, or the width, if you want to call it, equals 4. And now I can calculate the perimeter. Moving on to this question, and let's see where this is in the handout. This is on page 3 at the bottom. It says the perimeter of this shape is 58, and we're going to find the dimensions of the shape. So kind of what I mentioned at the very beginning, if I want to find the dimensions of the shape and the perimeter of this shape, I got to know what these missing portions of my graph of my figure are equal to. And I can find out this length because I know that working through, let me get my highlighter here, working through this, the height here, 4x plus 1, has to be equal to the addition of these two heights on the right side of the diagram. So 2x plus something is equal to 4x plus 1, but that's too hard to do in our heads, and we can use algebra more effectively, let our pencil do the work. 4x plus 1, and then you're going to subtract the 2x. You might want to put it in brackets to make it clear what's going on, so that you can find out that this is going to be equal to 2x plus 1 for that length. 2x plus 1. Let me get rid of that arrow. And going for the missing horizontal part, and I'll put this with a different color highlighter so we can see what's going on. 4x plus this missing portion has to be equal to 10x. So, I mean, this one should be pretty obvious, but I'm going to write the steps down because you know how picky Mr. Powell is for writing steps. The length of that missing part is going to be 10x minus 4x. And that's going to be equal to 6x. Okay, now that I've got those amounts in there, I want to just show you something important and that some of you guys have already picked up on. Let me get rid of this mess here, okay, for the what I wrote in. And it's asking me to find the perimeter. So how do I do this? Well, 4x plus 1 plus 4x plus 2x plus 1 plus 6x plus 2x plus 10. That is crazy, right? That's a lot of stuff to add up. And if you've been paying attention to what I talked about in class, I said that there's a much shorter way of doing this. We can actually just say that this length here, going along this edge, is going to be equal to the 2x plus 1 plus 2x there. And same thing with the other two sides. All right, they're already going to be repeated, I guess you could say. The 4x here with the 6x is also going to be equal to the 10x. So the shorter way of working out this perimeter, and you're allowed to use this, is to say it's going to be 4x plus 1 doubled and 10x doubled times 2, which would be equal to the perimeter of the whole shape. So that's another shortcut way that you're perfectly legal in calculating. Now be careful, because now I'm not finished. It says x equals 2, and I can find out the dimensions by replacing it in to all of those x values. Okay, and I'm going to mess up my page here. Hopefully it's going to come up clean on the next screen. And we fill in all of those x's, and we can get all those lengths in there. And so obviously this part here, this is 20, that's going to be 4, and that's going to be 5. And, whoa, don't know what's going on there. But we can find out the missing parts, and then we are going to be able to find the area of this by splitting it into two different area shapes. All right, so coming along there, we end up with 120 square meters. So hopefully this is making sense to you. Take a look at the work, and we'll be ready for the homework, page 1, 2, and 3, and page 6.